AI can write emails, generate images, recognize faces, recommend songs, and answer questions in seconds. So it feels like magic. But under the hood, AI is not magic at all. It is math, data, prediction, and a huge amount of training. In this video, we are answering one simple question: how does AI actually work? We will break down the core idea, how machines learn patterns, what neural networks are doing, how tools like ChatGPT generate responses, and where AI still falls apart. No buzzwords, no PhD required, just a mental model you can actually use. Welcome to how AI works. So before we get fancy, here is the simplest definition. AI is a system that takes information in, finds patterns, and produces an output that looks intelligent. That output might be a prediction, a recommendation, a classification, a generated sentence, or a decision. The reason AI feels impressive is not that it thinks like a human in some magical way. It is that it can process huge amounts of examples, compress patterns from those examples, and apply those patterns very quickly to something new. In other words, modern AI is best understood as pattern recognition plus prediction at scale. The easiest analogy is autocomplete on your phone. After you type a few words, your keyboard guesses the next one. It does not understand your life the way a person does. It has simply seen enough language patterns to make a strong prediction about what usually comes next. Modern AI works the same way, just at a much larger scale. Show it enough examples, let it compress the patterns, then ask it to predict the next token, label, action, or answer. The more relevant data and feedback it gets, the better those predictions become. AI has gone through a few major eras. In 1956, the field was named and early researchers focused on handwritten rules. In the expert systems era, humans tried to encode logic directly. Then machine learning shifted the field toward data. In 2012, deep learning broke through by using large neural networks trained on large datasets. In 2017, transformers changed language modeling. And by 2022, tools like ChatGPT made these systems feel mainstream. The big pattern is simple. AI got dramatically better when data, compute, and model design all scaled together. So what is happening inside a modern AI model? At the center is usually a neural network. You can think of it as a stack of layers that turn raw input into more useful internal representations. A sentence comes in as tokens. An image comes in as pixels. Each layer transforms those numbers a little bit, passing signals forward through weighted connections. Early layers pick up simple patterns. Deeper layers combine them into richer features and context. By the time the signals reach the output layer, the model can choose an answer, a label, or the next likely token. This is also where the vocabulary finally clicks. Artificial intelligence is the broad umbrella. Machine learning is the part where systems learn patterns from data instead of following only hard-coded rules. Deep learning is a smaller part of machine learning that uses large neural networks with many layers, and large language models sit inside deep learning. So when people say AI, they often mean a stack of increasingly specific ideas, not one single technology. Now for the most important distinction in AI, training versus inference. During training, the model sees example after example, makes a prediction, compares it to a target, measures the error, and adjusts its weights to reduce that error next time. That loop runs again and again across huge datasets. Once training is finished, inference is the fast part you actually experience. You type a prompt, upload a file, or show an image, and the trained model uses the patterns it already learned to generate a response in real time. Once you understand that AI is prediction plus pattern recognition, lots of products suddenly make sense. Recommendation systems predict what you will click next. Spam filters predict whether an email is junk. Face Unlock predicts whether the image matches you. Translation systems predict the best equivalent sentence in another language. Chatbots predict the next useful token. And fraud systems predict whether a transaction looks abnormal. Different products, same underlying story. Data in, patterns found, prediction out. Modern AI is also no longer just about text. Today's systems can work with language, code, images, audio, tables, and increasingly video. Text and code are especially mature because there is so much structured training data. Images are strong. Audio is strong. Video is improving fast but still harder because it combines space, time, and sound all at once. The big point is that AI is becoming multimodal. It can connect different kinds of inputs inside one system, instead of treating each medium as a separate world. Let's make the flow more concrete. You give an AI system some kind of task, a messy meeting transcript, a support email, a customer question, a photo. The system converts that input into numbers, runs those numbers through the trained model, ranks possible outputs, and returns the one it believes is most useful. That is why the same core engine can summarize a document, classify an image, draft a reply, or answer a question. The interface changes. The underlying logic is surprisingly similar. If you want the whole thing reduced to a few essentials, modern AI needs three things. First, data, examples the model can learn from. Second, compute, enough hardware to train those patterns at scale. Third, an objective, a clear way to measure whether the model is improving. From there, almost every modern AI system has two phases: training, where the weights are learned, and inference, where the trained model is used. And underneath all of it is one recurring job: predict the next best output. Another helpful way to understand AI is to look at the capability jumps. Rule-based systems were brittle. Backpropagation made neural networks trainable. Deep learning made perception much better. Transformers made language modeling scale. ChatGPT made that progress visible to everyone. And now multimodal systems are merging text, images, audio, and action into the same workflow. AI did not become powerful because of one magic breakthrough. It improved because several pieces finally started scaling together at the same time. This is also why the newest models are called multimodal. Instead of understanding only one type of input, they can combine text, images, audio, video, and structured data in one system. That matters because the real world is multimodal. A meeting has speech, slides, and decisions. A customer support case has text, screenshots, and account data. The closer AI gets to combining these modes well, the more useful it becomes in actual work. So where does all of this point next? In the near term, AI systems will become more multimodal, more agentic, and more personalized. They will move from answering isolated prompts to handling longer workflows. They will become better at using tools, better at working with files, and better at operating across text, voice, and vision together. That does not mean instant superintelligence. It means AI becoming more useful in more real contexts, because it can understand more of the environment around a task. But the most important part of understanding AI is knowing what it still does badly. Models hallucinate. They can sound confident while being wrong. They inherit bias from training data. They can be brittle when the prompt is weak or the context is missing. They can expose privacy risks if used carelessly. And large models are still expensive to train and run. So AI is powerful, but it is not magical, infallible, or self-aware. It is a prediction system with strengths and failure modes, and that is exactly how it should be treated. So here is the short version. AI takes inputs, learns patterns, and predicts outputs. Machine learning teaches the system from data. Deep learning uses layered neural networks to learn richer patterns. Training teaches the model. Inference is the live response you see. Modern AI is increasingly multimodal, increasingly useful, and still very imperfect. But now you have the real mental model. The magic is not magic anymore. It is just systems, data, math, and prediction at scale.